Welcome to the bilingual e-lecture for diploma students, to the third lecture on linear integrated circuits. So, in the previous lecture we introduced what is operational amplifier and the symbol of operational amplifier and the internal circuitry of the operational amplifier. So, now let us continue our discussion, right. So, this operational amplifier device is available in the form of IC, DIP IC, right, dual in line package. That means pins are arranged in the two lines, right. So, how to identify the top of the IC? So, there is a notch on this, or semicircle வட்டம் இருக்கு இல்லையா, இது வந்து this indicates the top side of the IC, and there is a dot, black dot here. This refers to the pin near to this dot is a pin number 1, right. So, pin number எழுதியிருக்க மாட்டாங்க, students you have to identify the pin number 1 like this, right. Again, so you have to count like from 1 the down 1 2 3 4 and the right side starting from the bottom 5 6 7 8, okay, right. So, 1 2 3 4 5 6 7 8. So, this is how the pins are numbered. So, you have to identify the external pin for the connecting the IC with the external circuits, right. Now, let us see what are the purpose of each pin, right. So, we already discussed that. நம்ம ஏற்கனவே பார்த்தோம் op-ampல 5 important terminal என்னன்னா 2 input terminal or output terminal, 2 power supply pins, right. So, there must be the pin in the IC when you pack this device for these 5 terminals, right. So, pin number 2 is the one of the input pin called inverting input pin. Pin number 3 is the another input pin, it is called non-inverting input pin, right. So, the important 2 input pin of the operation amplifier is pin number 2 and pin number 3, inverting input and non-inverting input, right. What is the next important pin? Output. Important terminal is output. So, what is the pin number? Pin number 6. Pin number 6 in this IC is the output pin, right. Then power supply terminals. What are the pins associated with power supply terminals of this device? Pin number 7 and pin number 4. நமக்கு தெரியும் op-amp ஆப்ரேட் பண்ணுறதுக்கு 2 வோல்டேஜ் தேவை, ஒன்று பாசிட்டிவ் வோல்டேஜ், அதர்வைஸ் அனதர் வந்து நெகட்டிவ், ரைட். பின் நம்பர் 7 பாசிட்டிவ் வோல்டேஜ், pin number 4 negative voltage pin, right. So, you have to connect your positive supply here, negative supply here, right. So, these are the 5 important pin of this IC to use this IC in your external circuit. What are the remaining pins? Pin number 1 is called as offset null. What is offset? So, in the operational amplifier, when both the voltage at both the inputs are equal, the output voltage should be 0, right. But practically there will be some voltage, it is called offset voltage. We are going to discuss it later. அதை nullify பண்ணுறதுக்கு we have a pin over here, pin number 1 and pin number 5, right. Pin number 8 is a NC pin. NC is abbreviated as not connected. So, there is no connection for this pin into this internal circuitry, right. So, you won't be using this pin, இந்த pin நம்ம யூஸ் பண்ண மாட்டோம், right. So, this is about the pin diagram of 741 operational amplifier, right. This we have already discussed. IC package IC 741 is available in the market in these 3 packages: metal dual in line package, metal can package, flat package, right. So, the dual in line package பற்றி ஏற்கனவே பேசிட்டோம். What is this metal can package and flat package? Let us see. This is the metal can package. See here, metal can package. See here in the DIP package pins are arranged in the 2 lines, right, because the chip is in rectangular form, but here it is in circular form. Here now how to identify the pin numbers. Rectangular chip la top edu bottom edu பார்க்கிறதுக்கு ஒரு notch இருந்துச்சு. இங்க எப்படி கண்டுபிடிக்கிறது அப்படினா, there is a tab here, right, tab. So the tab பக்கத்தில் உள்ள pin தான் pin number 8. From pin number 8 you have to in the counterclockwise direction, right, pin number 8 in the counterclockwise direction pins are arranged, right, 7 6 5 4 3 2 1, okay, and remain the function of each pin is same, similar to the DIP package, only package is different, function is same, right. So this is one of the package technique and this is a flat package, right. Now power supply connections, okay. இப்போ நமக்கு என்ன தெரிஞ்சிருச்சு, op-amp device வந்து in the form of IC single count la எப்படி கிடைக்குதுன்னு பார்த்துட்டோம். See one more point, the op-amp device is available in the form of IC, not only the single op-amp package, it is also available in double, quad. That means ஒரு IC குள்ள ஒரே ஒரு டிவைஸ் இருந்தா சிங்கிள், ஒரு IC குள்ள ரெண்டு டிவைஸ் இருந்ததுனா டபுள், ஒரு IC குள்ள 4 op-amp device இருந்ததுனா quad op-amp, okay. So there are different type of ICs based on the number of devices inside the chip is also available in the market. Marketல இந்த மாதிரி devices கிடைக்குது, okay. Now let us see power supply connections. Now this is your op-amp symbol, right, and in this slide we are going to learn how to connect the power supply to the device, right. So device க்கு supply கொடுத்ததுக்கு அப்புறம் தான் you can give the input, right. Supply கொடுத்த பிறகு தான் internal circuitry will work, okay, right. So you need to give 2 power supply, you need to connect 2 power supply to the operational amplifier, ஏற்கனவே பார்த்தோம். So one is plus voltage V plus, another one is minus voltage V minus, right. Also we learnt the pin number 7 is for connecting the positive voltage V plus, pin number 4 is for connecting the minus voltage V minus, right. Now you need 2 power supply, 2 DC power supply, 2 batteries shown here like this, right, and they should be connected like this. The negative terminal of the one source should be connected to the positive terminal of the other source, and this point should be grounded, it should be connected to the ground, right. So when you have 2 sources connected like this, ரெண்டு source இந்த மாதிரி கனெக்ட் பண்ணி DC source இந்த மாதிரி கனெக்ட் பண்ணிட்டீனா, now you get 2 polarity supply, right. So this is positive supply, you can directly connect this positive terminal of this source to the pin number 7, that is positive voltage. Similarly the other source, negative terminal of the other battery, you can directly connect to the pin number 4, that is negative voltage, okay. So simply you need a 2 power supply, ஒரு power supply ல நெகட்டிவையும் அடுத்த power supply ல பாசிட்டிவையும் கனெக்ட் பண்ணி அந்த டெர்மினலை கிரவுண்ட் பண்ணிட்டீங்கன்னா இப்போ உங்களுக்கு 2 polarity supply is ready, that is this is positive voltage positive, this is negative, but you have to choose the source battery with the same voltage, right. So here you see this is 15 voltage, this is also 15 voltage source, right. So when you connect like this, this is plus 15 volt, this is minus 15 volt, right. What is the operating voltage of operation amplifier? Operation amplifier will work on the range of voltage. Minimum the operating voltage starts from 5 volt to 22 volt, you can give minimum 5 volt, maximum 22 volt, right. So the typical voltage is in between the two, it may be a 10 volt or it may be a 12 volt or it may be a 15 volt, depends on your application, you can choose the operating voltage, right. So here I have shown the 15 volt source, so this is plus 15, this is minus 15, right. So this is how you have to create your connect your power supply, but the disadvantage is you need 2 power supply, 2 source. Is it possible to create two polarity supply with one single source? Yes, it is possible. எப்படி பண்றது? ஒரே battery connect to the use two capacitors, right? So using two capacitor connected like this, you can get two different positive and negative voltages using a single source. It is also possible. I have not shown the diagram here, and the diagram இங்கே காட்டல. Right. Let us know what are the manufacturer of op-amp. Okay. So இந்த op-amp device manufacture பண்ற company என்னன்னு பார்ப்போம். Right. Generally this 74 op-amp is originally manufactured by Fairchild and sold as MU-A741. Okay. So there are different manufacturer for manufacturing this op-amp device. Originally it is designed and manufactured by Fairchild company, right? Different manufacturer uses different type of code or initials to identify their company, and then type number. Okay. So in IC number you have a initial and type number. This refers to the, this indicates the manufacturer code. That means who is the manufacturer, யார் இந்த சிப்பை தயாரிச்சவங்கன்னு நீ பார்த்துக்கலாம் இந்த கோடை வச்சு. இந்த கோடு வந்து உள்ள என்ன சர்க்யூட் இருக்கு, this code number refers to the type of circuit inside the chip. Okay. The same, so MU-A741, MU-A is the manufacturing type code initial used by the Fairchild company, and 741 indicates the operation amplifier circuit. Okay. இதுக்கு முன்னாடி நம்ம பார்த்தா அந்த op-amp circuit, 4 stages of circuit. Okay. It is also manufactured by other manufacturers. Okay. The same 741 operational amplifier device circuit is manufactured by other companies like National Semiconductor, okay, Motorola, Texas Instruments, Signetics Corporation, but they use their own initial. National Semiconductor manufacturing the same 741 op-amp device, and they sold it in the market with the name LM741. The LM indicates the National Semiconductor company, that initial indicates the manufacturer National Semiconductor, and MC741, MC indicates the manufacturer Motorola, and the Texas Instruments is manufacturing the same IC with the code SN, right, SN52741, and Signetics Corporation is the other company, other manufacturer fabricating the same device with this name N5741. Now you observe that in all these IC name last 3 digit, last 3 digit பார்த்தீங்கன்னா எல்லாமே 741. Okay. So this last 3 digit 741 refers the actual type of circuit inside the chip. It is nothing but the operational amplifier. Understood? So these are all the only manufacturing code. Right. Now we are coming to the important discussion about the characteristics of the device. இதுவரைக்கும் நம்ம ஸ்ட்ரக்சர் ஆஃப் த டிவைஸ் பார்த்தோம். அதாவது டிவைஸுக்குள்ளே என்னெல்லாம் சர்க்யூட்ரி இருக்குது, அதில் என்னெல்லாம் பின் இருக்குது, எத்தனை பின் இருக்குது, ஒவ்வொரு பின்னு என்ன வேலை பண்ணுது, அதை எப்படி நம்ம எக்ஸ்டர்னல் சர்க்யூட்டில் யூஸ் பண்ணுறதுன்னு தெரிஞ்சிருக்கோம். அதோட பின் அந்த ஐசி நம்பர் என்ன இருக்கும், அந்த கோடு என்ன, மேனுஃபேக்சரிங் கோடு என்ன, நம்பரு, இதெல்லாம் பார்த்தோம். இப்போ ஃபங்க்ஷனுக்குள்ளே போகிறோம். இந்த டிவைஸை நம்ம யூஸ் பண்ணணும்னா இந்த டிவைஸோடைய கேரக்டரிஸ்டிக்ஸை தெளிவாக புரிஞ்சுக்கணும். ரைட். If you understand the characteristics very clearly, it is very easy to build the op-amp circuits, right? Okay. So it is difficult to understand the practical characteristics initially. Now let us see the ideal op-amp characteristics. What is meant by ideal op-amp? Op-amp, how the op-amp should behave ideally, right? So it's an operational amplifier circuit. Have four important ideal characteristics, right? So operational amplifier, ideal operational amplifier should have open loop voltage gain infinite, right? That what does it mean? It meaning enna, இந்த ஆம்பிளிஃபையர் ஆப்ரேஷனல் ஆம்பிளிஃபையருடைய ஓப்பன் லூப் கெயின் ரைட் டிஃபரன்ஷியல் வோல்டேஜ் கெயின் should be எவ்வளவு இருக்கணும் infinite. Ideally it should be very infinite, right. So what does it mean? That means operational amplifier have to amplify the differential input voltage. இந்த ரெண்டு நெகட்டிவ் இன்புட்டுக்கும் இன்வெர்ட்டிங் இன்புட்டுக்கும் நான் இன்வெர்ட்டிங் இன்புட்டுக்கும் இடையில உள்ள டிஃபரன்ஷியல் வோல்டேஜ் தான் இதை ஆம்பிளிஃபை பண்ணணும். ஓகே, டு தி வெரி ஹை கெயின், தட் இஸ் இன்ஃபைனைட், ரைட். ஸோ ஐடியலி open loop voltage gain, differential voltage gain is infinite. Okay, that means this says indirectly the Vd is 0. That means the potential difference between these two terminals is 0. What does it mean? That is, this point we will discuss later. Input impedance infinite. See, another important ideal characteristics of the op-amp is input impedance. So the input impedance of the operational amplifier should be infinite. What does it mean? It should not draw any current from the source, right. It should not draw any current from the source. Source ல இருந்து current draw பண்ணக்கூடாது. அப்படினா input impedance வந்து ரொம்ப அதிகமா இருக்கணும். Ideally it should be infinite, very high. So the output impedance is 0. Ideally general operational amplifier output impedance எப்படி இருக்கணும், கம்மியா இருக்கணும், லோவா இருக்கணும். Ideally it should be 0, right. So when the output impedance is 0, V not independent of current drawn from the output. Then what about the bandwidth? What is meant by bandwidth? So when you give AC signal to this device, the frequency comes into the picture. So எந்த frequency signal இது amplify பண்ணும், எந்த frequency signal வேணாலும் amplify பண்ணலாம். That is, bandwidth should be infinite. Any range of frequency signal the device should be able to amplify, that is bandwidth infinite. So to conclude the ideal op-amp characteristics, the four important ideal operational amplifier characteristic is open loop voltage gain is infinite, input impedance infinite, output resistance 0, and bandwidth is infinite, right. Another two characteristics, important ideal characteristics, is CMRR. What is CMRR? We will discuss it about the CMRR later, right. So common mode rejection ratio, that also should be very infinite, that should be infinite, right. But so in the previous slide we learnt what are the ideal characteristics of the operational amplifier, right. But practically it is very difficult to achieve infinite voltage gain, infinite resistance, 0 output resistance, and infinite bandwidth. Practically it is not possible. So what is the practical characteristics, practical op-amp characteristics? Then why did we learn ideal characteristics, right? Because to theoretically understand the device, understanding the ideal characteristics is important. It will be very easier to analyze the circuit with the help of ideal characteristics, right. Now practical device, the open loop voltage gain in ideally it should be infinite, but practically it is very high, in the range of 10 to the power 5 to 10 to the power 6, right. What is 10 to the power 5? 1 lakh, right, to 1 crore. So the gain value maybe it should be very high, practically in the range of 1 lakh to 1 crore gain. Then what about the input impedance? Ideally it should be infinite, but practically very high. For what? For ideally it is infinite, that means 0 current it will draw from the source, that means it will not draw any current from the source, but practically some negligible current in both input terminals will be going into the op-amp, right. So ideally current flowing into the op-amp is 0, practically some small amount of current, negligible amount of current in the range of microampere, maybe in the nanoampere. Then output impedance, ideally output impedance must be 0, practically it cannot be 0, it is very low, in the order of ohms, milliohms, and bandwidth ideally it should be infinite, practically it is very high. That means it can amplify any frequency, right? Even very high frequency signal you can give it as an input, it can amplify, that is the meaning, right? So with by understanding these 4 important characteristics, it will be easier for the understanding of the further circuits. So let me conclude, gain is very high, input impedance very high, output impedance very low, and bandwidth is very high, CMR are also very high. So this is the characteristics curve, input output characteristics curve of the operational amplifier. What does it mean? How to interpret these characteristics? What do you infer from this characteristic? நம்ம இதில் இருந்து என்ன தெரிஞ்சுக்கிறோம் அப்படின்னா, simple, op-amp உடைய output, at the output of op-amp, that is voltage at the output V0, V0 refers to the output voltage, Vd refers to the input voltage. Okay. So when your Vd refers to the differential input voltage. What is differential input voltage? Op-amp have 2 input, inverting input and non-inverting input. Inverting input la you can give one voltage, non-inverting input another voltage. ரெண்டுக்கும் உள்ள difference is a differential input voltage. Okay. So Vd refers to the differential input voltage. ரெண்டு input voltage க்கு உள்ள difference x axis ல இருக்கு and V0 is in the y axis. So this curve indicates what? When Vd 0, differential voltage 0 இருக்கும்போது output voltage 0. Differential voltage input change கூட கூட, that means when Vd keep on increasing, output also linearly increase. Now you see here output voltage linearly increased with respect to the differential input voltage, that is why it is called linear IC, right? But up to some level, what happened after this point? So when Vd is 0, output voltage 0, and when Vd keep increases, output voltage also linearly increases with Vd. So this is linear region, and when Vd, after this point when Vd increases, there is no increase in the output voltage, output voltage is saturated, right? So this is called plus V saturation voltage. Similarly in the negative side you have a minus V saturation voltage. So the operational amplifier can operate at any time, at any point of time, output voltage of the operational amplifier can be in between these 2 voltage range, that is between the plus V saturation and minus V saturation, right? So it cannot exceed the plus V saturation at minus V saturation. So that is the meaning of this characteristics curve. ரொம்ப simple. So நம்ம என்ன தெரிஞ்சுக்கணும்னா, suppose if you are giving a power supply voltage, for op-amp needs 2 power supply. For example, let the power supply is 10 volt, right? So plus VCC is a plus 10 volt, minus VE is a minus 10 volt. அப்போ என்ன அர்த்தம் அப்படின்னா, and what is V saturation? Plus V saturation, it should be less than the plus VCC, let it be 8 volt, okay, and minus V saturation less than the minus VE, right? So let the plus V saturation is plus 8 volt, minus V saturation is minus 8 volt, okay, plus VCC is 10 volt, minus V is minus 10 volt, right? So the meaning is operational amplifier output voltage always in between the plus 8 volt and minus 8 volt, that is the meaning, okay. So at any point of time the output voltage of the operational amplifier cannot exceed this range. So let me conclude whatever we have discussed so far, right? So we have learnt the important characteristics of the operational amplifier, ideal characteristics of the operational amplifier, practical characteristics of the operational amplifier, and we also understood the input output characteristics of the op-amp. என்ன புரிஞ்சிருக்கோம்? op-amp ஓட அவுட்புட்டில் at any point of time output voltage வந்து சப்ளை வோல்டேஜுக்கு மேலே போக முடியாது, சப்ளை வோல்டேஜுக்கும் போக முடியாது, ஓகே, சப்ளை வோல்டேஜுக்கு கீழே தான் இருக்க முடியும், ப்ளஸில் வந்து it is called plus V saturation, மைனஸில் minus V saturation, ரைட். ஸோ அதை தான் இதில் தெரிஞ்சுக்கிறோம். ஸோ அந்த வோல்டேஜுக்கு கீழே it is in the linear mode, in the positive side also in the negative side, op-amp operates in the linear region, right. ஸோ இதுக்கு மேலே போச்சுன்னா op-amp is saturated, so the voltage will be always plus V saturation in the positive side and minus V saturation in the negative side. Thank you.